What is up, people? Welcome to another video. In a previous video, we've taken a look at Redis, what it is, its configuration, replication, and persistence, and how to write an example application that reads data and writes data to Redis. In this video, we're going to take everything we've learned and we're going to take a look at what it takes to run all of the stuff on Kubernetes. So without further ado, let's go. Now, there are two main things that are important in this video. Number one is replication. We're going to deploy 3 instances of Redis. Now, to replicate, Redis has the concept of master and replica. We will always have one master and a minimum of 2 other replicas. Now, we also want to be able to scale these up. In a distributed system like Kubernetes, pods can come and go. So we're going to need to ensure that these pods can find the current master. If a pod dies and comes back, we need to be able to find and join the current master. The second most important thing is high availability. When a master dies, the Sentinel's job is to promote another replica to a master. So the Sentinel does the failover. So we're going to be running Redis Sentinels to form a cluster out of the Redis pods. In my example, for learning purposes, I will be deploying the Sentinel separate from my Redis replicas. Sentinel's job is to form a cluster and do the automatic failover if one of the masters die. When a Sentinel starts, the first thing it'll need is who is the master. Now, out of these 3, any of them can be a master, so we'll need to do something so that the Sentinel can discover who the master is, probably in a init container. Once the Sentinel knows its master address, it'll do everything else automatically. It'll contact the master, find the replicas, find the other Sentinels, and form a cluster. This will allow us to scale the Sentinels at will, but we'll need a minimum of 3, else the cluster failover will not work. So there is one thing I want to mention about running Redis on Kubernetes that's very important when it comes to high availability. So Redis has a really good document around the topic of Sentinel, and there are some fundamental things you need to know about the Sentinel before deploying. And one of the things I want to stress is that there is no HA setup which is safe, which basically means you need to test your Redis instances to make sure that they can tolerate disruptions. So if a pod dies and comes back, you want to make sure that you don't have any disruptions, and you want to make sure that your applications can tolerate these disruptions. So if you're totally new to Redis, please check out the links below. I made a video on the basics of Redis, as well as running Redis on high availability mode with the Sentinel. In that video, I cover replication and the Sentinel in much greater detail, and we're going to be taking a look at how to run Redis with replication in mind using the Sentinel service on top of Kubernetes. So if you're new to this channel, everything I do is on GitHub. So if you take a look at my GitHub repo, I have a folder called storage, and in that folder I have a Redis folder, and under that I have a folder for Kubernetes. Everything I do is going to be in the Kubernetes folder in a README, and this is all the steps we're going to be looking at today on how to run Redis on top of Kubernetes. So be sure to take a look at the link down below to the source code so you can follow along. So the first thing we're going to need is a Kubernetes cluster. Now, I like to use Kind, which basically allows me to create disposable Kubernetes clusters on top of Docker. So in this demo, we're going to say Kind create cluster. We're going to create a cluster called Redis, and we're going to use Kubernetes 1.18.4. So this takes a couple of seconds to run and we're good to go. So now I have a Kubernetes cluster up and running. I can say kubectl get nodes, and we can see we have 1 node up and running. The next thing we're going to want to do is create a namespace. Now, a namespace allows us to group and hold all these resources together. So we're going to say kubectl create namespace Redis. Now the third thing we're going to need is a storage class. So if you do kubectl get storage class, this will show you all the storage classes options that's available for your cluster. Now this will be different depending on your cloud provider. I've made a separate video about persistence volumes, which I linked down below for you to check out, which basically covers persistent volumes, different types of storage for different cloud providers, as well as storage class. Storage class allows us to define the type of storage we want to attach to Kubernetes, and then we can use a persistent volume to attach that storage to a container. So in this video, we're going to use the standard storage class, which is basically just a local volume to allow us to persist data on our host. Now the next part of this demo, which is very important, is the configuration. So if you take a look at the GitHub repo, I have a storage Redis folder. Under that is the Kubernetes guide. And inside the Redis folder, we're going to be taking a look at how to deploy a bunch of Redis pods and then have them replicate, authenticate, and form a cluster. So the first thing is the configuration. We have a Redis config map, and here you can see I have a config map called Redis config, and I have a Redis conf. Now Redis has great documentation around configuration, and they have a config file that's the defaults for every Redis version. So what I've done is I've grabbed the Redis 6.0 config and I've pasted the config in here as is. Now, the first thing we want to talk about is authentication. Now, in order to authenticate, we need to put the password inside of the configuration file. So what I've done is we have two pieces here. We have the require pass, which is the password used for any app or CLI to connect to this Redis pod, and then the master password, which is basically the password for any of the replicas to talk to the Redis master. Now, because we're running a bunch of pods on Kubernetes, the plan is to run pod 0 as the master on startup. And remember, because we're going to be running a cluster with failover, at any given point in time, any of the pods can become a master. So that's why we keep the password between the master and the required password the same. This will allow replicas to talk to the current master. It'll allow the master to talk to the current replicas. Now, the next bit to talk about is Redis replication. In my high availability video, I spoke about replication in much more detail, but basically what it boils down to is the slave of key. This basically tells this Redis instance where the master address is. Now, you can see I have it commented out. This is just to show you what it would look like, but remember, we're going to have to dynamically generate this value on the fly, and I'll show you how to do so. When Redis starts up, we're going to want to make pod 0 the master. Every other pod in our cluster will connect to pod 0, and then the Sentinels will take over. So when cluster failover happens, the Sentinel will be able to promote any replica to a master. So it's very important not to hard code this value. The next piece I want to talk about is persistence. Now, in order for Redis to persist its data, I've spoken about the storage class and the persistent volume. Now, to enable persistence in Redis, there are two things you have to know. There are two modes. One is RDB mode and append only file mode. I cover this in great detail in my HA video, but just at a very high level, RDB mode is where Redis dumps its database file to disk at various intervals. This is good for performance because it takes up a bunch of compute every time Redis dumps the file to disk. But it's also not as durable because if Redis had to die in between those intervals, there is a chance of data loss. Append only file mode is a little bit better for durability because it writes every transaction as it happens to disk, which is good for durability but not so good for performance, so it's a trade-off. The Redis community recommends that you run both. So what I've done is if we search for data, we can see I have a dir key, and this tells Redis where to write its data to. So I've created a folder here called /data, and this is going to be where our persistent volume attaches to the container. So the next piece is to turn on append only mode. So you search for append only. I've turned it on, so append only equals yes, and then I've also specified the append only file name you want to use. So it's just going to be called appendonly.aof. And then to turn on RDB mode, you can just tell Redis what DB file name you want to use. So I just say dump file dump.rdb. So to deploy this, all I need to do is change directory to the storage Redis Kubernetes folder, and then I'm going to say kubectl apply in the Redis namespace, and I'm going to deploy this config map. This will give us a basic config map that each of the Redis pods can use. So now that we have our config map deployed, the next thing we want to do is deploy our stateful set. So if we take a look at the Kubernetes Redis folder, we have a Redis stateful set YAML file over here. Now, stateful sets are very important to run stateful workloads like databases. The reason is, first of all, we need to provide a stable DNS name for each of our Redis pods. So we need Redis 0, Redis 1, Redis 2, and so forth as we scale up. Each pod needs to be individually addressable, which is not something a deployment does. Stateful sets give our pods a persistent network identity that persists across reboots. The other thing that stateful set gives us as well is the ability to mount separate volumes, generate volumes on the fly, and mount them into each of the pods automatically. This is again something that a deployment does not do. If you're interested in stateful sets, I've made a video about it. The link is down below. Be sure to check that out. So here we run a very simple stateful set called Redis. We run 3 replicas, and you can see we're running containers called Redis. We're going to be running Redis 6.0, and we're going to be starting up Redis with our custom configuration. We're also going to be exposing the port for Redis, and we're going to be mounting our data volume into the container over here. Now, this is the path where Redis will be writing its data. If you scroll down, you can see that we are using a volume claim template. So this will tell the stateful set to issue storage using the storage class that we have earlier. So every part of the stateful set will get its own persistent volume, and it will be automatically mounted into the container. And then we also have a headless service type type cluster IP none, and this will give every single pod a stable DNS record. So we'll have Redis 0, Redis 1, Redis 2, and so forth as we scale up. Now, one important thing to note here is that I'm creating another volume mount for the Redis config map. So you can see Redis config, I'm mounting it to etc Redis. But if you take a look at the volume, it's not really the config map, it's an empty directory. This is really important because Redis needs write access to its configuration. This is because at any given time, the Redis replica might be promoted to master, so it needs to be writing details to the configuration on the fly. For that reason, it's not great to use a config map, because if the pod recreates, it'll get the config map back and the details will change. It will not know how to connect to the current master. It won't know how to find the sentinels either. This is important because if the Redis pod dies and gets recreated, we don't want it to get the default config again. We want its configuration file generated on the fly. So to achieve that, what I have is an init container. This is a container that starts up before all the main containers in the pod. So you can see I have an init container called config, and this guy's job is to generate the config map on the fly. So you can see I have a volume mount here, and I mount the config map into temp Redis. And then what I do is I actually copy the temp Redis config into the real Redis config location. So this container will attempt to contact the Sentinel to figure out who the master is. If the Sentinels are not running, it will default to Redis 0. If this container is Redis 0, it will do nothing because it's the master. So we achieve this by running a simple bash script. We say Redis CLI Sentinel, we try to ping the current Sentinel. If that fails, we say master not found, and we try to default to Redis 0. We do a quick check to see, are we Redis 0? And if we are Redis 0, we simply do nothing because we are the master. If we're not Redis 0, we update our slave of value and we point to Redis 0 by default. If the Sentinel is found, we run the Redis CLI, we try to connect to the Sentinel, we then say get master address by name, and we get the IP address from the Sentinel of the current master. And then what we do is we update the slave of key in our config to point to that master. So you can see we're heavily reliant on the Sentinel to do the cluster failover, do the leader election, and then we just contact it and point to that master. Remember that any given time a pod can fail and restart, the node can fail, the pods can be moved to different nodes. You have to make sure that you test all of these different types of disruptions. Now I've also taken a look, and there are a ton of different communities and different Helm charts out there to deploy Redis, but make sure you don't fall into that trap of just blindly deploying it. You want to make sure that you understand how the replication works under the hood. You can see in the demo that I've just showcased you that I've basically taken an approach of trying to learn exactly how the Sentinels communicate, how the master leader election works, and how pods can come back to the cluster and join it in the event of a failover. So make sure you really go over your requirements and understand what you need from Redis, and then use this video as a foundation to understand how the Redis Sentinel works, how replication works, and understand all the different failure points that can happen. So to deploy the stateful set, I'm going to say kubectl apply in the Redis namespace, and I'm going to apply that stateful set file. That's going to go ahead and create the stateful set as well as the service. I can then say kubectl get pods, and I can see we have a pod up and running. Now this Redis pod is figuring out who the master is. It'll realize that it's the master because there's no Sentinel up and running, and it'll update its configuration to say there are no slaves. And then you can see Redis 1 and Redis 2 are now also coming up. From a storage perspective, we can say kubectl get pv, and we can see that 3 persistent volumes have automatically been created by the storage class and mounted to the stateful set pods. Now you want to make sure that each instance is healthy. So to verify that, we're going to take a look at the logs. So we're going to say kubectl logs on Redis 0, and we can see that it's starting replication synchronization. So we can see that this guy is the master. Similarly, I can run kubectl logs on Redis 1, and I can see that master replica sync has started. It's connected to its master successfully. The same thing goes for Redis 2. We can see it's connected to its master and it started synchronization. We can also then test our replication by saying kubectl exec, and we can go into the Redis 0 instance. Once we're in, we can run Redis CLI, and we can authenticate saying auth with our password, and then we can run the info replication command. And we can see this is the replication info. So we have role as master and it has 2 connected slaves. So this is a good way to test whether replication is working. And now we have one master and we have 2 replicas running in Kubernetes. Now what if one of the replicas died? It doesn't really matter because the replica will find its master anyway, as I've showed earlier. But what if the master dies? This is where the Redis Sentinel comes in. The job of the Sentinel is to form a cluster and also allows for cluster failover. So if the master dies, the Sentinel will promote one of the replicas to a master. Now to deploy the Sentinel, we have to take a look at the Kubernetes folder, and in here I have a Sentinel folder where I have a Sentinel stateful set file. And here we also have another stateful set for 3 replicas of a Sentinel. And this time what we're going to do is we're going to run a container called the Redis Sentinel. It's going to run Redis 6 and it's going to start it up as a Sentinel, passing in the Redis Sentinel configuration. We're going to be exposing port 5000. That's going to be the address that the Sentinels talk to each other. Now, very similarly to our Redis implementation, we also mount in a configuration volume, and you can see that volume is also empty. That is, we're also going to be using an init container to generate our configuration on the fly. Now, you can notice that we don't have a config map defined here. That is because we're going to just generate the entire config from an init container because it's very simple to do. Now, this is very easy to do with the Redis Sentinel because when the Sentinel starts up, all it needs to know is where is one of the Redis instances. So we can loop through a bunch of address names for Redis 0, Redis 1, and Redis 2, and the init container can go and contact any one of those instances. In the case of Redis 1 being down or Redis 2 being down, we can just loop through that list and find one of them that should be up. And then we can contact that node, find out who the master address is, and then point the Redis Sentinel to the master. This is all that the Sentinel needs. Once it connects to the master, it will be able to find all the replicas that are part of the replication and the cluster, and it will find all the other Sentinel addresses as well. This is part of the behavior of the Sentinel. So let's take a look at our init container. We have a container called config, and we're running another image of Redis so we can have access to the Redis CLI, and we're running a shell script here that contains our Redis password. You can mount this from a secret, and we have a list of nodes that we're going to be looping through. So we got to assume here that there might be Redis instances that are down. So it's a good idea to take the entire list of instances and then loop through them. So what we do here is we take the Redis CLI and we run Redis CLI info replication, and we try to grep out the master host address from each of the instances. Once that is found, we can then update our Sentinel config by saying Sentinel monitor my master with that master address that we found. And then you can see I'm taking the simple bunch of commands here to generate a Sentinel configuration file that's pointing to that master that it found. Once the init container has created the Sentinel configuration, the Sentinel will start up. It'll automatically go and find the master address, find all the replicas, find the other Sentinels, and form a cluster. So to deploy it, it's very simple. We're going to say kubectl apply. In the Redis namespace, we're going to apply the Redis stateful set YAML. That's going to create the stateful set as well as a service to contact each of the stateful set pods. We can then say kubectl get pods, and we can see that we have 3 Sentinel pods up and running. And to make sure that the clustering has worked, we can take a look at the logs on one of the Sentinel pods. And what we're interested in is to see that it's monitoring a master. So it found a master on that address. It also found 2 slave nodes, and it also found 2 other Sentinels. So you can see the Sentinel is really good at finding all the replicas once it's located the master. So now, as I said earlier, it's very important for us to test cluster failover. So what I want to go ahead and do is simulate a failover by deleting one of the pods. So I say kubectl in the Redis namespace get pods, and we can see we have all our pods up and running here. So what I'm going to do is I'm going to delete the current master. So I say kubectl delete pod, and I delete pod 0. Now to see what the Sentinel has done, I can get the logs of that Sentinel by saying kubectl logs Sentinel 0, and we can have a read down the logs to see what happened. And if we take a closer look, we can see that it's done a switch on master. So it's switched to this IP address, and it's also indicating that it can connect to all the slaves, and it's marked the current master as a slave, saying slave is down. And if we run kubectl get pods o wide, we can see the current IP addresses for the Redis pods as well as the Sentinel pods. And if we take a look at the switch statement here, it's gone ahead and switched the master to this IP address. So if we take a look at the IP address here, we can see that Redis-2 is now the master. Now to verify that, I can go ahead and exec into Redis 2 pod. I can run the Redis CLI, I can authenticate, and I run info replication. And now I can see that it has taken up the role of master and it has 1 connected slave. So when pod 0 comes back up, it'll become a slave and connect to this master. We can also see if we go back into Redis 0 and run the same commands, it has now taken the role of slave. You can also see if I say kubectl get pods O wide, you can see the IP addresses of each of the pods. And if we take a look at the logs of the new Redis pod that came up, we can see that it's finding its master, it found the Sentinel, it found the new master, and it's gone ahead and updated its configuration. And if we jump back into Redis 2, which is the current master, we can see its info replication. It's taken the role of master and it now has two connected slaves. So Redis 0, which was the master, went down. The Sentinels promoted Redis 2 to the current master. Redis 0 came back, contacted the Sentinel, got the master address, and reconnected to the master, which is Redis 2. So the next step is what happens when one of the Sentinels dies. So what I'm going to do is I'm going to go ahead and delete one of the Sentinel pods, Sentinel 0. Now technically nothing should happen. This Sentinel should come back, it's going to loop through the addresses, contact each one of the nodes, it's going to ask who the master is, it's going to contact the master, find out then who the replicas are, and connect to the Sentinels. So this should cause no disruption to our replication and our clustering. If I say kubectl logs of the Sentinel, we can see that it's gone ahead and detected who the current master is there. So it's connected to IP address 10, which is Redis 2. It's also gone ahead and connected to both slave addresses, which you can see here is Redis 0 as well as Redis 1. And then it has the two Sentinel commands here. So it's picked up two Sentinels, one on IP address 14 and IP address 16, which is Redis Sentinel 1 and 2. So hopefully this video was helpful for you to understand the fundamentals of running Redis on Kubernetes. If you're new to Redis, be sure to check out my basics videos on Redis as well as my clustering guide. And let me know down in the comments what sort of videos you'd like me to cover in the future. Now also remember to like and subscribe. If you want to be a part of the community, be sure to check out the links below to the community page. And if you want to support the channel even further, be sure to check the join button and become a member. And as always, thanks for watching, and until next time, peace.